Dear students and participants of the course on railway engineering, today initially we will start back with the turnout design and then we will move into the maintenance aspect of the turnouts. In the previous lecture, we discussed about the number of crossings. We talked about the various methods so that this number of crossing can be calculated on the basis of the angle of crossing. Then we talked about three methods which are used for the design of turnout: the Coles method, an alternate method and IRS method. Towards the end, we discussed about IRS method and we solved and tried to find out the equations so as to calculate the lead and the radius. In today's discussion, we will be continuing with those. We will solve a numerical on that. Then we will talk about the curved turnouts, then the turnouts which are required for high speed movements. And then finally, we will be discussing about the inspection and maintenance in terms of switches, points and crossings. So, if you remember in the previous lecture towards the end, we talked about these two equations. The total lead is G minus T minus H sin alpha into cot of alpha plus beta by 2 plus H cos alpha. So, if we are considering only up to this point, then that was the lead, and when we added H cos alpha, it became the total lead. And this radius was given by G minus D minus H sin alpha divided by cos of beta minus cos of alpha, where alpha is the angle of crossing, beta is the angle of switch, H is the distance from the TNC up to which the curve stops. Let us look at numerical with respect to this IRS method. So, we have a broad gauge track, that is G is 1.676 meters, 1 in 8.5 turnout, so it is N is 8.5. Straight switches are being provided. Turnout curve ends 864 mm ahead of the TNC, so small h is also defined. Hill divergence small d is 136 mm. Switch angle beta is given as 134.27. We have to calculate the length of the lead and the radius of the turnout. So, given the data, because we have been given n, what we require is alpha. So, we are calculating alpha by the right angle triangle method, that is n is equals to cot alpha. What we get is alpha as 642.35. Now, the total lead is given by the equation as we already talked about. So, we are just putting the values here. So, G is 1.676, D is 136 mm, so in meters. So, sin then H given as 864, so it is taken here. Then the sine of alpha, then cot of alpha plus beta by 2 and again H into cos of alpha. So, it gives us TL is equals to 20.73 meters. Then we calculate R. R is G minus D minus S sin alpha divided by the difference between cos beta and cos alpha. So, again if we put the values there, what we are getting is R is equals to 222.36 meters. So, these are the two values which are required if we are working with IRS method. Let us look at another numerical. Here this again a broad gauge track. So, G is 1.676, there is a 1 in 12 turnout. So, N is given as 12, hill divergence is 133. So, small d is 133, crossing angle alpha is 445.49. So, alpha is 445.49 and switch angle is 108.00. So, we have beta given here. There is a straight length between TNC and the tangent point of crossing, that is 1.418. So, this is small h value, or this is small h value is also given to us. Now, again we are required to calculate the value of TL and R. So, using the equation of the TL and placing the values there, what we are getting is 29.084 meters. Similarly, if we use the equation for R and we put the values there, what we are getting is 437.38 meters. So, as I said previously, these are the two values which are required and these have been calculated. So, only thing is that the formula is a bit lengthy, but otherwise you can directly put in the values and you can get the results. Now, the another modification of the switches, so far what we said that they are not the curved switches. In the case of switches, the tongue rails, they are straight. So, if everything is being made curved, so the radius of the turnout for the curved switches is calculated by this formula, that is G minus T minus H sin alpha divided by 2 times of sine of alpha plus beta by 2 multiplied with sine of alpha minus beta by 2, and this can be transformed as cos beta minus cos alpha in the denominator. So, G is known to us, H is known to us, that is the distance at which it is stopping alpha and beta. They are also known, that is angle of crossing and the angle of switch, and T is basically a thickness. Now, distance from the toe of the switch to the point where the tangent drawn to the extended lead curve is parallel to the main line gauge face. So, we have a main line gauge face, we have the toe of the switch. So, at this point is the heel, and then we have the toe. So, from the toe, it says from the toe of the switch to the point where the tangent drawn to the extended lead curve is parallel to the main line. So, if these two are going parallel, so a tangent, if it is being made here at that point, so that is the distance we are talking as L, which is given by equation as shown here, that is R into sin alpha minus in bracket G minus T minus H sin alpha multiplied with cot of alpha plus beta by 2. Similarly, the distance between the main rail gauge face and the tangent drawn to the lead curve at a distance of L from the toe. So, from the distance, the toe is here, the heel is here. So, from a distance of here we are taking from this toe a distance of L. In that case, that distance which is coming is usually, as we used to talk about over sign, similarly that terminology is being taken here, and that is V is equals to G minus H sin alpha plus R into 1 minus cos alpha, that is whole in brackets being subtracted from G. The switch lead, this is calculated by a formula given here, which is under root of a big equation, which is 2R into D minus Y minus the square of D minus Y minus 1. Now, here Y is what? Y is the vertical coordinate along the Y axis, and as I said the T is the thickness of the switch at the toe. So, that thickness of the switch at the toe, like if we are talking about the tongue rail, we discussed that it is 6 mm value. Now, factors which are causing low speeds on the turnouts are what? There is first of all the sudden change in the direction of the running edge upon entry onto the switch from a straight track. So, you are coming from a straight track, you are going to take a turn. So, here the points switch are being provided. So, all of a sudden there is a change in the direction and you are entering onto the switch. So, switch is now a combination, an arrangement of different type of elements, different type of fixtures. So, that is at that particular location the low speeds are required. Then absence of a transition between the curved lead and the straight switch. So, you have a curved lead here and there is a straight switch here. So, there is no transition in between. If there has been a transition, then the transformation of the speed will be easier, but it is not there. So, there is an absence of the transition between the curved lead and the straight switch, as well as between the curved lead and the straight crossing. So, this curved lead and the straight crossing which is coming here. So, we are talking that at distance H from T and C, we are making it straight. So, the curve is here only. Then absence of the super elevation over the turnout. So, we are not providing any cant here. There is a gap in the gauge phase and the running table at the crossing. This is another issue, and there is a variation in the cross levels due to raising of the switch rail. So, we are increasing the height of the switch rail or the tongue rail. They are the one and the same, and that is being increased by 6 mm. If you remember, we did talk about this. Now, what are the features of the turnouts for speeds above 100 kilometers per hour? Let us talk about that. So, provide long curved switches to avoid abrupt change in the direction of the vehicle at the entry of the switch. So, we already talked about what type of curved switches can be there and how we can calculate the lead and the radius in that. Provide the curve to the switches and the crossings same as the radius of the lead curve. So, whatever is the radius being provided for the lead curve when it is going in this direction as compared to the straight section. So, the crossings here as well as the this switches, these should also be provided with the same value. So, this is R, so this one is R and this one is also R. Provide a transition curve between the toe of the switch and the nose of the crossing. So, provision of transition curve, we did talk about there is a problem, the transition curve is not being provided, and that is the reason that there is a jerk, a jump can be there, and that is a problem. Now, permit higher Kent deficiency to compensate the disadvantages of not providing a super elevation on the turnout. So, we are trying to compensate it in terms of the Kent deficiency. Then for goods yard's which are being considered here, we are talking about the high speed turnouts which are being considered in the case of goods yards for a maximum permissible speed of 25 kilometers per hour. In the case of passengers yards, its speed can increase to 50 kilometers per hour. In the case of the periphery of the big yards for bypass lines, it can further be increased to 75 kilometers per hour, and the junctions of the single line and the double line for a maximum permissible speed of 100 kilometers per hour we can consider, and this standardization has been done. Now, say for passengers yards with the maximum permissible speed of 50 kilometers per hour and the turnout is 1 in 12, what are the things which are there? The overall length is kept same as the conventional 1 in 12 turnout with consideration of easy replacement. So, the length is not being changed here. The thick web tongue rail, these are used to provide high lateral rigidity and longer life to the turnout, because the speeds are increasing. Therefore, the dynamic effect of the speed will come in terms of the lateral forces. Use of a special spring leaf clip to fasten the inner foot of the stock rail and thus prevent non-lateral rotation at the stock rail head. So, this is another issue. If that speeds are more, there is a possibility of a lateral rotation which may happen at the head of the stock rail. So, as to reduce that, the special spring leaf clips they are used. Use of sturdy fittings on the outside of the stock rail to minimize the dynamic gauge widening. This is another aspect. Some design features are given here for the same condition of passenger yards with a 50 kilometers per hour and 1 in 12 turnout. Total length 39.659 meters, lead 27.386, radius 141.36, crossing angle 445.49, switch angle 0.20. You can see here the switch angle has been reduced a lot, and that is allowing to go for a higher speed because now the length of the tongue rail is also increasing. And 52 kg rail section with the wooden sleepers having a spacing of 550 to 600 mm is what we are using. The non-overriding thick web switch of JAD U249 type, that should be a part of this design. Then CMS crossings with rail clearances as 44 mm at the throat, 44 mm at the opposite nose, and at the end of the flare it is 64 mm. The slope is 1 in 31 at the crossing, and the check rail clearances which are provided, they are 41 mm at the opposite nose, and at the end of the flare slope it is 63 mm, and here the flare slope is taken as 1 in 68. Now, let us start discussing about the inspection and maintenance of the points and crossings. So, first of all we will take the general maintenance requirements, and then we will talk about the points, switches and crossings. So, here in the case of general, the points and crossings, these shall be laid without 1 in 20 cant unless otherwise it is being specified in the design. There are no junction fish plates being used at the stock rail joint or at the heel of the crossing. Then we have to weld the stock rail and the lead rail joints. So, lead joints means it is the lead rail joints. So, they needs to be welded, and we talked about the spherical washers. These are a special type of washers which can be used in even the inclined conditions or when the faces are at certain angles. So, that is again being talked here, that special spherical washers on the skew side to flush fit the head of the nut of the bolt with the web of the rail should be used. So, yeah, that is another thing which can be checked. Then ensure the correct spacing of sleepers as per the type of the turnout. So, for different type of turnouts, the sleeper spacings are defined, and if you remember when we were discussing about the sleepers in one of our lectures, there we have talked about that in 1 in 8.5 what type of spacings are required. They are variable spacings, they become constant after certain number of sleepers, and similarly in the case of 1 in 12 also we have looked at those spacings. Then clearance at the toe, clearance at the heel of the switch, jack rails, wing rails, they needs to be checked whether they are within the permissible limits or not. Then the various fastenings like chairs, fastenings or fittings, these needs to be checked so that they are in position and are being tightened, they are in not in a loose condition. Then packing under the sleepers, that means we are talking now about the ballast. There should not be an issue with the ballast, it should not be loose, it should not be defective. Then otherwise we have to go for the screening or the deep screening of the ballast. If there is a possibility of a creep and or a creep has been observed on that track, then we also need to see that whether the elastic fastenings they are working perfectly fine or not. So, that check has also to be made. Now, in the areas where there are large number of points and crossings, like if we talk about marshalling yards or sidings or the terminal stations, at those particular locations, a maintenance schedule has to be created for each and everything. Like for point, what should be the schedule, for crossing, what is the schedule, for switches, what is the schedule. Talking about the maintenance of the switch, the badly worn or the damaged stock or the tongue rails, they needs to be replaced. But what are the conditions when these needs to be replaced are being written here. What it says, if it is chipped or cracked for cumulative length of 200 mm over a length of 1000 mm. So, if you are going for a 1000 mm long, there may be a possibility at some locations some material has got chipped. So, cumulatively what is this size is what we are considering here, and that should be within those 200 mm. Chipping, what is chipping in this case? What the material which is coming out, how it is being defined is, it is defined that it is worn out to a depth of 10 mm for a continuous length of 10 mm. So, this has to be not less than 10 mm so as to define that this is a chipping. If it is less than that, then may not be considered. If it is badly twisted or bent, which is causing a gap of 5 mm or more at the toe, then also we need to go for the maintenance of the switch. Or if the wear on the stock rail exceeds the limits, and what are the limits? We are just going to talk about those next. So, the wear limits of the stock rails, they are being defined here. The loss of section, in the case of 52 kg per meter rail, 5% is 6% is the limit. In the case of 60 kg per meter rail, the limit is 7%. Due to corrosion, there is again a problem. So, the wear can be there. The limit we have already discussed when we talked about the various defects. So, here it is 1.5 mm in the web or the foot. These are the two areas where the corrosion mostly happens. The vertical wear is defined as 8 mm or 13 mm for a lighter section, that is 52 kg per meter, and a heavier section, that is 60 kg per meter rail section. Then lateral wears, they have been defined for the curves as well as for the straight sections, and they are also being classified on the basis of the category of the route. So, if we talk in terms of the curves, so A and B are being clubbed together and C and D, they are clubbed together. In the case of A and B, the limit is 8 mm, whereas in the case of C and D, the limit is 10 mm. Similarly, in the case of straight sections, for A and B it is 6 mm and for C and D it is 8 mm. Then another thing which needs to be done is the lubricating the gauge face of the tongue rail, and the gap between the top of the leading stretcher bar and the bottom of the stock rail, it should be between 1.5 mm to 5 mm. Then tongue rails shall bear evenly on all the slide chairs, means you have the two tongue rails. So, there is a tongue rail here and on the other side also the tongue rail is in this form. So, if it is touching here, there will be a throw on the other side and they are being connected by the stretcher bars. So, we are talking in this case the tongue rails shall bear evenly on the slide chairs. So, the sliding chairs are provided below so that it can move easily. In closed condition, it must bear evenly against the slide blocks. So, whatever slide blocks are provided, it should fit in easily in that. Now, talking about the maintenance of the crossing side, the reason for damage to the nose of the crossing, it needs to be first of all identified before we go for a renewal. Without identifying that, if we renew, we may find that again and again that damage is occurring. And to avoid the hitting of the nose, because when you are coming from one side, so at this nose, if the wheel is moving in this direction and there is a possibility of hitting on it, it shall be ensured that the check rail clearance should be between 41 to 45 mm for fan shaped turnout. So, the check rails which are provided here and its gap with respect to the other rail, that is what we are talking. Then in obtuse crossings, the distance between the throat and the nose must be maintained correctly. Now, what is that distance between the throat and the nose? So, we did talk about it. So, this is the way the crossing is being created, and then there is another rail which comes here and then goes in this direction and flares, or another rail which is coming in this form and then it goes in this direction and flares out. So, this is the throat and this one is the nose. So, that is what we are talking, the distance between the throat and nose must be maintained correctly. The diamond crossings, the obtuse crossings should be laid square to each other with respect to the center line of the acute crossings. Then maximum permissible vertical wear on the wing rail or on the nose of the crossing is 10 mm. So, that is already defined. If you talk about a high speed roads, that is Rajdhani or Shatabdi roads, then conditioning or resurfacing of welding shall be planned by reaching the following wear limits. As soon as these wear limits have been reached, we need to go for that reconditioning. In the case of built up or welded crossings, we talked about the various types of crossings. So, there we said there is a built up crossing, there is a combination of a built up another crossing, then CMS crossing. So, that is what we are discussing here. In this case, for a built up crossing, the limit is 6 mm, but for CMS crossing it is 8 mm. And deductions needs to be made in the above wears for CMS crossings on account of the cant of 1 in 20. If because of the cant of 1 in 20, there will be some movement. So, that movement that which is coming within the wear area, if you are calculating in that form, that needs to be removed. So, that deduction of D will be there. Then on CMS crossings, another deductions in terms of the 52 kg per meter rail section is 2 mm, for 60 kg per meter rail section it is 2.5 mm, and for heat treated welding crossings it is 3.5 mm. So, these are the limits. And talking about the maintenance of the lead portion and the turn in curves, we have to check the war signs at stations at 3 meter intervals. If you remember, in the previous lecture we did talk about the slews and we talked about the realignment of the track, and there we were talking about that we have to take the war signs at different distances all along the chord, and then the first summation, second summation, that needs to be looked at, as well as we have to see that what are the values at the start as well as at the end of the curve, which should be 0. So, this is what we are discussing here. It says that check the var signs at stations at 3-meter intervals. It should not be more than 3 mm at each station in the lead curve as well as in the turn in curve. There also, in the case of individual readings which needs to be taken at individual stations, we had a limit. You can revisit that. Now, check var sign of the turn in curves on loops at stations at 3-meter interval for sharpness of the curve. So, in the case of sharpness, there we have noted another value, that was the cant or the superelevation. If the wear on the switches or the crossings this exceeds the limits which are already being specified, then we have to go for the renewal of the points and switches. And the another criteria here is if the total traffic which has come on these points and switches. So, the minimum value which needs to be considered before going into the renewal of points and switches are being given here in the case of the two rail sections, that is 52 kg per meter and 60 kg per meter rail section. So, it is fabricated switch, thick web switch or CMS crossings. The values they are ranging from 150 to 500. This is the range of a gross metric tons. Then the renewal is, if the renewal of the sleepers is due, then also the renewal of the points and switches can be taken up, or if the rail section has to be changed, then obviously this will come up. While renewing, the layout shall be improved. So, if there is any issue with the alignment, that can be looked at this point, because then there is no other opportunity to do that. The standard rail sections only should be used. At least one rail length on either side of the turnout should have the same section of rail as turnout. So, if in case there is a possibility that you are going on a turnout and here in this section some other rail section is going to be used for a certain distance beyond, the same rail section should be there. Only after that only there should be a change in the rail sections, and whenever there is a change of rail section, we did talk about a combination in terms of a combined fish plates to be used to connect to those rail sections. Now, joints on SRG and lead rail, they should be welded. Then the new gauge tie plates, they needs to be fixed. Before connecting stretcher bars, tongue rail be examined regarding its fitting with the stock rail. We have discussed about the various types of switches, overriding switches and those. So, that is what we are talking here, that the stock rail and the tongue rail which has become, it is being planed to a thickness of 6 mm. So, it should come and fit in with that. So, if the tongue rail is not fitting properly against the stock rail, then we have to go for the jam crowing, and this we have discussed when we were talking about the buckling of the tracks and all. Now, before renewal, the ballast should be deep screened. So, as and when we go for a renewal of the track and everything is being taken out, it is always good that we check whether there is a requirement of deep screening of the ballast, and if it is, we do it, and then again we relay the track. The ballast, first of all, if the deep screening is being done, it is placed up to the bottom of the sleepers, and some extra material or the ballast has to be kept ready, so that once this is being done and everything is going to be placed, then packing of the sleepers on the sides can also be done using that material. Then there are two methods by using of which we can do the renewal. So, it is a building up at the site, that is a manual method. In this method what we do is that all materials which are required for the turnout, they are brought to the site and the assembly is being done there. So, everything is brought there, every fittings, the types of rails which are required in terms to be used as a stock rail, in terms to be used as a tongue rail or other things, they are brought there and then they are placed in correct position after the dismantling of the old turnout. The another one is the slewing of the pre-assembled turnout at site. In the case of the realignment of the track, we discussed about this slewing. And what was this slewing? That we had a track which has gone maybe in some variations. So, if those variations are there in this track with respect to the chord, so we are trying to identify, we have a proposed var sign versus the existing var signs, and we did some calculations there. So, the layout is assembled by side of the existing layout. That means we are putting those pegs to do that, and the ground on which the turnout is to be assembled is leveled. If necessary room is not available, then what to do? Additional space is created by doing extra earthwork or by constructing a working platform with the old rails and sleepers. Okay, so this is to be done, maybe afterwards that material will be removed from that location. Assembly is usually built on a rail grid, the top surface of which is greased beforehand to facilitate easy slewing. During the block period means when the trains are moving in the blocks, when on these particular tracks, they are divided into blocks. So, if there is a train here which is moving in this particular section, block section, then there cannot be a train in this block. There can be a train in this one, with the caution being shown that there is a train moving ahead of you. We will be talking about these type of control systems when we will be taking up the train movement control systems. So, and removed and pre-assembled layout is slewed to correct position, aligned and packed. And finally, pre-assembling and laying with mechanical systems can also be there. Of course, this type of a mechanical system we will be discussing towards the end in the last module, where we will be taking up the drainage, we will taking up the maintenance of the tracks. So, those mechanical system will be taken up at that point. Now, the last thing which we are looking here is that how the sleepers are placed at the points and crossings. So, you can see there is a straight track going and then there is a turnout. Here the sleepers of the same size are being used, but then there is a sleeper which is getting in between the two straight sleepers, and because of this arrangement it is known as interlaced sleeper. The problem here is that if you have to pack this ballast which is available in this small area, it is very difficult to do that, and there is a possibility of the deformation of the curved track. The another method is the through sleepers, means at this location we are using the sleeper which are longer in length, and as soon as you are away there is a possibility of using a smaller one, we again start using the smaller one. The only issue is that you now need to manufacture the long sleepers and you have to carry them to the site and you have to put into the location. So, that is a bit cumbersome condition. Otherwise, in this through sleepers there will not be a problem of say ballast packing and all those things. So, here in this case another advantage will be that both the tracks are also maintained at the same level. So, with this we close our discussion now. What we discussed about the turnout design, we talked about curved turnouts, then we discussed that what are the requirements if the turnouts needs to be there to cater to the high speeds. Then we shifted to the inspection and maintenance of the switches, crossings, laid rails, curved sections, points, etc. And finally, we have looked at the arrangement of the sleepers at the points and crossings. Thank you. We will be meeting in the next lecture.